hear me okay? I'll give this a shot. I have my headset on now. Is everything coming through okay?
So far, so good.
Great. Okay. So that's a little better now. Sorry about all the trouble, folks. I'm not sure what's going on today. The beauty of virtual events. Anyway, yeah, just a little bit about the Chicago chapter. So we, Adam, and a few others have been running the chapter for what's been like 8 years or so. We have, over 1,300, I think, members now. So quite a few people. We try to meet at least once a quarter. COVID has been a little challenging just with logistics, as you can see, and I kind of miss seeing everybody in person. But I'm glad we can get this group together and at least do a virtual event. I'm not sure how much you heard of the other intro, so I'm just going to go over it again. We have two speakers today. One is having audio troubles right now, but we'll hopefully get that resolved soon. And then Jeff Williams from Contrast Security will be with us a little later. He's going to be speaking about Java Sensor Observability Toolkit that he's created and open sourced. And Jeff he's a security vet. I'm sure many of you have known him or seen him around at other conferences like Black Hat, RSA, QCon, and etc. So he'll be with us a little later on. Garth, how's it going?
I think I've sussed it out. Anyways, let's see what happens. Do I hear myself?
I can hear you.
Is it my same bad jokes just repeated back at me as in some sort of special hell?
I think you're sounding good now, Garth.
Right, okay. I think I had an out of MacBook experience. Do I try again, or do I say the magic words OWASP Ottawa and it keeps coming back at me like a bad burrito? Anyways, so OWASP Ottawa, I think I've already said it a billion times, 1,300 plus members. We have done in the past workshops and presentations. This will be changing moving forward because we will probably lose our Shopify venue as they sort of decide not to have office space in the new realities. We will looking at doing different things in terms of how we present and other offerings that we can think of as we go along. So it's a brave and exciting world to try to innovate in. That's really all I can say, other than OWASP Ottawa is really made successful by all the volunteers and people that help.
All right. Thanks for that overview. And then St. Louis is the other joining chapter. Eric, do you want to say anything about St. Louis?
Yep. How's it going, everybody? So I'm one of the chapter leads for St. Louis, Missouri, along with Joe Blanchard, and our training lead is Andre Van Claveren. So we try to meet at least every quarter with speakers, and usually have a pretty well attended, at least for our chapter CTF. So we throw in at least a couple of those every year. So join us on Slack, Twitter, Facebook. It should be all OWASP St. Louis. And check out the meetup.
All right, great. So I'll introduce Garth. Garth is going to be our first speaker. He's going to be talking about SSRF, the 20-year-old new sensation. So I'm excited to hear about that. As I won't spend any time introducing Garth. I think he's the OWASP Ottawa Chapter Co-Founder, as he just introduced. But he's been a software developer, hacker, and a security architect. So without further ado, Garth, take it away.
Thank you. I'll see if I can share my screen without disturbing everybody's audio. One moment, please. All right, let me know when you can see that. Is it good? All right. Okay, so I probably should say something about why I decided to do a presentation on SSRF. And the reason is that I have an out-of-body experience with SSRF, in that I know the attack and I've been involved in the attacks and tried to protect companies that have had the attacks in terms of catching it in development. But whenever somebody says SSRF to me or server-side request forgery, I just cannot connect the two. And so I will draw a total blank on it. And that means I have to run away and get my notes and reread it and relearn it. And so the issue then becomes, well, how do I get this past the hippocampus? And so in my research for this and working with this, the goal of this presentation was essentially to help me remember, and thinking that, oh, people, I have this issue in terms of trying to tie SSRF with the actual attack. Perhaps somebody else would need that as well. And maybe they're overworked and busy and exhausted like me. So what I'm going to do is I'm going to talk about the attack itself. I'm going to talk something about the naming because I have this naming thing with it. Some examples, well-known examples of it in the wild. Its habitat, some tools we can use around it, and the usual, how do we fix it? As was mentioned, I'm a co-lead at OWASP Ottawa, not a co-founder, a co-lead. Founder goes to my colleague Sharif Kusa, who created OWASP Ottawa in the dark days in the wilderness. My background is electrical engineering, and I became a builder, and then I started to get into braking, and overall I'm working in architecture. Yes, I'm older. So I've been in this game for a while, and currently I'm a consultant for an organization called Devious Plan. And any claims that I look like Vladimir Putin are not accurate. So what is it? Server-side request forgery. It's got one of those names, you know, you add a beat, add the word baby, and you have a hit. Not. And so the problem I have is that piggybacking on the name client-side request forgery, I don't think it really explains well enough what's actually going on. And yeah, we can say, okay, it's server-side, so we know what's happening on the server, but I think where my brain falls over with it is the actual word request, because we typically are talking between the client and the server for the request. And so that's where, when I'm trying to remember it or somebody asks me, I can't really connect the dots. But it's well known, as the CWE describes it there, as a architectural weakness. Okay, so we know it's an attack. We know it's against the server, but in this particular attack, we're trying to trick the server into making requests on our behalf. So we're really, as in the client-side request forgery, we're trying to piggyback on the authorization of the actual client session. Here we're doing it at the server. We're trying to actually behave or use the credentials or the status that server has within the internal environment and piggyback on that relationship. So also known as, you may have heard of cross-site port attack, which is actually, when you look at the definition of it, it's actually a special case of using SSRF, where you're actually doing an SSRF to enumerate ports and try to attack other ports internally. I've also heard the phrase out-of-band resource load. That's another one that just, I don't know, just maybe it doesn't work for me. But I've heard of that in some of the PortSwigger forums. So you may have heard those. It's got known associates. You may have heard of XML entity injection. So it is another form of that. And the, hang on, I just need to get a breath of air to be able to say this next one. Improper restriction of rendered UI layers or frames. I don't know. It's another name, but it doesn't work for me either. It has a family affiliation in the CWE as the confused deputy, so it belongs to a category of attacks of duping something else to do our bidding, also known as the confused deputy. And of course, confused deputy has a big definition, which I am not going to read here because I'll probably just get myself more confused. But essentially, it's saying all the things we've said before in terms of being able to use the status of the server to do our bidding. So it's got impacts. Clearly, if we're able to exploit a SSRF, we can access data within the server itself or within the network it resides. We can use it to potentially enumerate things within its subnet or beyond, depending on the network configuration. We may potentially be able to do an RCE, but we can also try to do attacks against other servers, whether internal or external. So in this way, it would be a great proxy for an attacker to be able to attack other things and make it look like the original server suffering from SSRF. So in general, we're trying to access those services that are not intended to be exposed on the internet. And so that might give us an opportunity because they may not be as well protected if the target has not followed a defense in-depth strategy. Of course, it's not limited to HTTP. We can do a number of other things outside of that protocol. But probably the most devastating of this attack is if it was susceptible within a cloud environment. And that's because we may be able to use the status of that server to be able to access cloud-based metadata APIs. And we'll see a specific case of where that was particularly dangerous. All right, so fundamentally, we're able to read stuff, we're able to potentially change stuff, and we may be able to execute stuff. And that's maybe more of a definition I can get behind sometimes. So what's in a name? How did it get this name? So if you start doing some searches for that particular name, you can find some references. And the oldest references I found for SSRF was CVE 2013-0235. So that's 2013, not that long ago. But if you look at other references, particularly the common weakness enumerations, the CWEs will point to a CVE 2002, where we start to see the name actually not being used, but the attack being very well described as being the same thing. So then, obviously, this is only what I've been able to find in terms of what is documented. We know that there will be much older cases of this coming about. So how did it get the name and where did it come from? And so the earliest possible reference I've been able to find for this was a ShmooCon 2008 presentation by a guy whose name I did not put on this particular slide. Yes, Daryl Hyland. Can't read my own slide. And he presented this particular attack call, or this presentation, Web Portals, Gateway to Information, or a Hole in Our Perimeter Defenses. And that was the first time that has been documented that that name was proposed. So I went hunting around to see if that was actually the case. And so I asked the question, hey, is this the original naming for it? And the nice thing about internet, and particularly Twitter, is that sometimes it comes back at you. And so what I learned from this is that the name was originally proposed there, but it took a long time for that name to work through the system. And in fact, conversing with Daryl, he mentioned to me that, well, they had tried to create a Wikipedia page and start with it, but Wikipedia wouldn't accept it because there was no history. So of course there was no history because the name was never used before. So this is the earliest time we can find server-side request forgery being used. So these will be some exploits that you will probably heard of. There was the Capital One Customer Zero attack, where there was a very significant breach and a lot of personal information exposed. 100 million Americans and 6 million Canadians' personal data was exposed. And that was the usual roster of phone numbers, incomes, names, addresses, social security numbers, and in the Canadian version, the social insurance numbers. So everything to make a complete dossier of someone else. And that came down to a couple of things. Fundamentally, there was a misconfiguration. It's the cloud, what do you expect, right? So they had a web application firewall that was misconfigured, and that enabled somebody to use that WAF to query the cloud metadata service. And in this case, it was AWS. And the thing is when you use the metadata API, you're actually able to get a token that gives you the authorization, a bearer token, to give you the authorization of what that server was. In what was particularly devastating about this case was that that server was overprivileged. It did not follow the principle of least privilege due to the misconfiguration. So the attacker was able to get a token. Hey, I'm God. What else can I do with this? So they were able to then access a great many things, as that 106 million people were about to learn. The other one, and I know probably a lot of people use Jira, but the next one that was of significance was a Jira CVE last year. And in this case, it was a standard internal service needs to access an internal resource or another external resource, and it takes an URL to be able to find that resource. And what was interesting about this was that they were actually doing sanitization. They were validating the URL they got. In this particular case, the attacker had a bypass. And what they were able to do was use the @ symbol to be able to bypass the sanitization. So where does this, what is this type of attack, and what does it need, and where does it live? So typically you need 3 things for SSRF, and you can get away with 2 if you want to do blind SSRF, but let's go with 3 because that's simpler. So the first thing you need is the injection. You need something that is taking some link or some, let's call it a pointer to some external resource, and it needs to be unsanitized, or it needs to be taken in and accepted verbatim. The next thing is what I'll call the fumble, where either, so it's not being sanitized and it's being handled internally and it's being taken as being valid and being used. The deeper attack on this is that potentially if it's using an URL parser, you can try to attack the URL parser. And if you follow Orange Size, if I'm pronouncing that correctly, he had an excellent Black Hat talk that goes into detail about attacking URL parsers. So I'll point you to that in that case. But there is some sort of fumble going on, whether it's in the underlying URL parser or in the code that's actually handling the URL. And then the third element is the response. And so whatever we're doing with that original injection, somehow we're able to get the information back, whether it's we're enumerating ports and we're getting some kind of response that allows us to indicate yes or no back. And of course, blind SSRF is where we're not getting anything back, but we're trying to use out-of-band methods to figure out whether or not something happened. All right, so how do we find the injection? How do we see that? Where does it live in the wild? And this is occurring because a server requires an access to an external resource of some kind, whether it's a file or a thumbnail image or something like that. And so you can find that in those kinds of features, but fundamentally it needs access to an external resource. So the suspected features where you'll see this is file uploads, give me an avatar. Sometimes it's document and image parsing. Sometimes it's link expansion, webhooks or proxies, and PDF generators. So if you're scanning an application, these features will be juicy potential targets. So if you're looking at traffic, then the easy spots are if you're seeing anything, any parameter that has a URL or a partial URL. And of course, that also includes JSON data. So anything that looks like it's referring to something external or even a file for that matter would be potentially a juicy target. There are other things that are probably a little harder to find, whether it's some sort of data format that implies some sort of encoded XML or some form of encoding. Headers are not exempt from this type of attack, as well as SVG images, which are fundamentally XML. The one thing that I sort of was surprised about was open graph tags in metadata tags. So what kind of tools can we apply to be able to expose this or find this? And one tool is something called DNS bin, and there are some examples of that. And that's essentially would be useful in a blind case where I want to see if something's looking up a DNS. So there will be sites that will give you your random domain, and you can use that in your injection, and then you just wait and see if anything's made the DNS call. Following on the naming scheme of SQL map is a tool called SSRF map, which essentially takes a pre-canned request. So say you've captured a request in burp, you save the request and then you pass it on to this tool, and it will attempt to determine whether or not there is an SSRF vulnerability in the request. OWASP Zap, of course, as well as Burp Suite and plugins, as well as some others that I won't go into, SSRF Sheriff, Gopherus, and GF Patterns, but I've not looked at those others. I've just found the names. So DNS bin, hey, there's an URL. You can set up your own server. So there is a GitHub link there to the actual server, but they have a sample running. And you essentially, it essentially looks to see if you're making a DNS request has occurred based on the URL you've injected into your target. There's another one that's based on the similar thing called requestbin.net. And like I mentioned before, this is useful in a blind case where you may not necessarily be getting any response back to your client. SSRF map, so it's automated, it's based on Python, and it takes that pre-canned request. The repo seems to be reasonably active up at least until February. I don't know, maybe hopefully the contributors are still okay. It has a module-based approach where you can attach different modules or engage different modules within it if your attack on the back end is Tomcat or MySQL or others. And then the GitHub page will, or the GitHub page will go through the entire list of modules that it contains. And then there is OWASP Zap, which, hey, it's OWASP, so we have to talk about Zap. Shout out to Rick, who is one of the OWASP Ottawa colleagues and volunteers who's involved heavily within the project. Somewhere in the background, I'm hearing somebody go, woohoo! Anyways, so detection. So if you go into preferences and options, you can actually look for the callback mechanism. The challenge here is that you need your Zap to be reachable by the target over the internet. So however you set that up, that's something you have to configure to be able to have OWASP Zap actually hear any responses back. But you fundamentally specify a port and domain. Don't choose random port, especially if you're trying to listen, because that just won't work for you. You may need to do SSL or non-SSL as appropriate. And the one thing I've noticed about this particular interface is that you can make changes, but the tester will not change unless you click on OK. So if you change the actual remote address, it won't update in the tester. So you have to click on OK, then go back into the interface, and then you'll see the updated tester to use. There are, as far as I can tell, no built-in scanner rules for SSRF within OWASP, but there is a GSOC in 2020 that's proposed it for an external SSRF service. The exploitation in this case would probably mean that you would be wanting to use a fuzzer in this case. And then what you would be then doing is using your attack strings to see if you can actually do your enumeration through the fuzzer. So you'd be building a list of potential attack strings and waiting for a response, or using a DNS bin to see if you are actually getting anything back. And then, of course, there is Burp that has the collaborator tool, which gives you that external DNS query exposure. Of course, similar to Zap, we're going to use Intruder and maybe Repeater for trying to enumerate and getting responses, and the scanner does scan for SSRF. There is a plugin for OWASP by Tobias Osfeldt called Upload Scanner, which specifically attempts to scan and look for vulnerabilities in any upload functionality, and that also tests for SSRF. So, what are the fixes? How do we avoid this? And I remember, well, just today I was looking at this list, and it kind of sort of left me wanting. And the reason for that is that of all these things, except the code documents itself, I just had to throw that in because I'm out of control. The thing about each one of these is that I know of cases where each one of these has failed. In the case of Jira, input validation failed. In the case of Capital One, stateful firewall failed because of a misconfiguration. That might also apply to network segmentation. So I think what really is the issue here is obviously not just one thing. It's all of them, and reviewing all of them to avoid all the failures that have enabled SSRF to live in the past. So it's a case of vote early and vote often. It's do all of them, do them regularly, and not become complacent. In the cloud case, since the Capital One vulnerability or exploit, AWS has sort of revisited their metadata service and came out with IMDS v2. And this was an attempt to try to raise the bar to avoid similar issues like Capital One. And in this case, how the actual service querying or trying to get a token from the metadata service is they're looking for a few things. You need to do a put request, which is often not the case or not available to the attacker using SSRF, as well as to avoid proxy type attacks, avoiding the X-forward 4. Monitoring is important because it's a case of, are we aware, are we able to sense in our environment that something's making a request that it shouldn't be, and it's having a high level of knowledge about your environment to be able to understand the difference. Static code analysis in the case of infrastructure as code in this case would be very, very important to avoid those misconfigurations that would allow overprivilege, as well as code software that's handling the request with the URL to be able to understand what they're doing with it. But again, each one of these things cannot stand by itself. Yes, I see Rick's in the background in the chat going whoop whoop. So I'll say OWASP zap again, and I'll see something show up. So that's that was my learning approach and introduction to SSRF. I'm just going to have a quick look to see if there are any questions in the chat. And sorry again for the déjà écoute problem with the audio. Just waiting for the delay on the stream to YouTube. So while we're waiting for the delay in the stream to YouTube, maybe maybe somebody could ask me a question in the Zoom call. Anything, ask me anything. What's the weather like in Ottawa? Who won the FA Cup in 1967?
I got a question. Can you explain Crown Land?
Crown Land.
I'm kidding. Well, actually,
not to be confused with Crown Royal.
How old is Zap?
It's what we just had on the PSA. I think it's just past 10 years, right?
Yeah, just had a birthday, right?
Yeah, just had a birthday. If I go back to find, excuse me, I will get rid of this and I will attempt to find the PSAs, and I will the core root set. No, that's not it. Zap turned 10 on September 7th. Happy birthday, Zap. Let's see if there are any questions. No, I think, nope, Rick says it's 10 and September 6th. Was that vodka? No, it was not vodka, because I don't look like Vladimir Putin. So I wouldn't be drinking vodka. It's actually a G&T. What's a G&T? I'm about to hear, right? Gin and tonic. That is a lime in the G&T, yes. Any other questions, drinking or otherwise? All right, well, given that, I thank everyone, and I apologize again for the audio kerfuffle at the beginning, and I will let you continue with the next speaker.
Awesome. Thank you, Garth. All right. So Jeff, you are on, I think, right?
I am here.
Yeah. All right. So quick introduction. Jeff Williams. I think a lot of you may have come across Jeff. He has over 20 years experience in security, so security vet, CTO and co-founder of Contrast Security. A couple interesting points, I think, in his bio, I just want to call out. He's recently authored in DZone, DevSecOps. I asked RASP ref cards, and he frequently speaks at major conferences like Java 1, Black Hat, QCon, RSA. And one thing OWASP related is he's a major contributor to OWASP, and he was a global chairman for over 9 years. And he actually helped create the OWASP Top 10, the Enterprise Security API, the OWASP Application Security Verification Standard, the cross-site scripting prevention cheat sheet, and many more. So really honored to have Jeff with us tonight. So without further ado, I'll hand it over to you, and you're going to talk about the open source Java sensor toolkit tonight, right?
I am. I'm super excited about it. So thanks to Michael, and thanks everybody. I used to live in Ottawa, actually. It's been a nice summer there. I've heard it's a little rough in the winter, though.
No, it's okay.
Yeah, today I am. Thanks for the nice introduction. I am super excited to talk to you about the I'm calling it the Java Observability Toolkit now, and I think you're really going to like it. Let's see. I did want to mention. I want to thank everybody for being a part of OWASP. It's incredibly important to the future of software and the internet and your kids' futures that we do a better job of securing the world of code. And you can make an immense difference. So I'm really, thank you so much for your participation. I got a lot of information in this talk, so I'm going to go pretty quickly. Please, if you have any questions, please interrupt me or wait till the end and ask questions. I think it's the best way of really dealing with COVID is to actually interact on these. I'm spending my whole life on Zoom, but if you interact, it'll make it a lot more fun for everybody. So I'm going to share my screen here, and oh, my cursor's going crazy. There it is. I'm going to share my screen and get started. Okay, so I wanted to start with a few facts about application security that we've gathered and contrast over the past 12 months. And this is just to kind of set the stage of the problem. And I know you guys have heard this from a bunch of sources probably, but I just want to make sure we're all on the same page. So we're not doing well at securing code. Look, I wrote the OWASP Tab 10 18 years ago, and it's still the same shit in there. So we're not making the kind of progress that we should. I mean, 96% of applications have at least a vulnerability. The average software project is introducing 1 or 2 new vulnerabilities a month. The average application's got more than 30 vulnerabilities, plus more than 2 higher critical open source flaws. If you look at on the attack side of things, it's equally grim. The average application gets attacked over 13,000 times a month. 0 applications that we monitor out of tens of thousands of applications, 0 were not attacked every single month. And interestingly, 98% of those attacks don't connect with their intended vulnerability. So look, it's just, when you have a ton of vulnerabilities and a ton of attacks going on, we're not in a very good place. And I'm really proud of all the work that I and many others have done at OWASP, but we're not getting it done. The results aren't nearly good enough. So we've got to do something different. So, I encourage OWASP to take crazy experiments on and try different things, because what we've been doing isn't working. It's not gonna get better just by trying harder. I wrote on the crew team in college, and I had my coach come to me one day. He said, "Jeff, you're like an acorn, and I want you to turn into a mighty oak tree. And every time I coach you, you just row harder. You're not turning into an oak tree, you're just turning into a giant acorn." And I'm afraid that's what's going to happen at OWASP, is we're not going to actually make a difference. We're just going to turn into a giant acorn and not really ever blossom into a tree. These are probably what you sort of expect in terms of attacks and vulnerabilities. Attackers are not stupid. If you look, most of the attacks match up to where you see most of the vulnerabilities, which sort of makes sense. It looks to me like attackers are spending more time on expression language injection and command injection than you would think from the likelihood of the vulnerability, but that's because the consequences of those attacks are so serious. That's a complete host takeover. So the attackers are adjusting for risk and balancing out their attacks. It looks to me like XXE is a nice opportunity here. It's more likely than what you see in terms of the attack traffic. So it's certainly one to be aware of. And I just wanted to call to everyone's attention, for those of you who haven't been in this field for that long, that we've got many decades of work trying to secure applications. And it goes all the way back to formal methods in the 70s. I got involved in the late 80s working in the trusted computing environment in the government. We tried to build standards for mandatory access control and high assurance, and it really didn't take off. We tried CMMs for a decade. There was a trend of vulnerability disclosure, which really didn't make any difference, although it caused a lot of controversy. We've tried pen testing. We're not going to scan or test or static our way secure. The OWASP Top 10, as I mentioned, didn't really make any difference. WAFs haven't really provided significant defense, and so on. I've trained thousands of developers in secure coding, but there's no way we're going to train our way out of this. There's like 30 million developers in the world, and at best, a few percent of them have ever gotten any decent application security training. There's no possible way we're going to make a dent in that way. And I'm really excited about DevSecOps. I really love it, but I'm afraid if we don't, really figure out something different, make it, really do some significant change, and not just take the stuff we're doing today and dump it onto developers. That's not really shifting left. That's what I call shitting left. And we've got to make we've got to do something remarkably different if we want the outcomes to change. So I wanted to share this story about a company that I've worked with. Their CEO recognizes that they are transforming their company into software. They are a Fortune 100 insurance company, and they said, look, we're not an insurance company, really. We're a data and technology company that happens to sell insurance. And so they're putting all this effort into digital transformation and DevOps, and security is a challenge for them. They've got all these different problems. And I talked to their CIO about it. He said, security is limiting how fast we can innovate. He said it was impedance, that security is adding story points to every single thing they do. And as long as that's true, security's going to get bypassed. So we have to figure out ways of doing security faster. And I'll show it this way too. Because if AppSec is a drain on innovation, it won't be effective. And so like the way we're doing AppSec today, and I'll just draw out the whole picture so I can talk about the whole thing. But most companies do it this way. Their developers write some code, maybe use some libraries, feed that into their development environment and their development pipeline. And along the way, we do a bunch of scans for stuff, different kinds of scans. Some are early, some are late. We also might use a WAF at the end of the process. But out of these scans, we're getting both true and false positives, lots of false positives. And the problem is that all of those errors that these tools make end up having to be resolved by experts. And there's just not enough experts in the world. There's so much work coming out of these things. I've seen organizations that are, regularly piling up a security backlog with tens of thousands of vulnerabilities in it. And there's just no way to sift through it all and figure it out. So, very few of those really effectively make it back to developers. Many organizations deal with this problem by cutting down the scope of what they're working on. They don't look at all their applications. They just look at the most critical ones. And they don't look at all the different kinds of vulnerabilities. They only look at results that are higher critical, forgetting that these tools are reporting lots of things that are actually super important as mediums and lows. And so we're doing all this work. There's all this impedance. And the results are really not very good. We're not producing secure code. And we're slowing down the flow of business value. And this is really what makes security so tough, is when we slow down the delivery of business value, then people are going to work around us. So again, we don't get to say what the pipeline looks like. We have to fit into the pipeline. It's clear after decades of working in software and security that people are not going to change the way they build software for security. So we have to figure out ways of being compatible with the way that people are building software. Okay, so that's the gloom and doom part. This is the exciting part. Instrumentation is super powerful. So this is the 9450. It's an instrumented basketball, and it's got a bunch of sensors in it. Those sensors measure dribble speed and shot rotation and the arc of your shot and makes and misses and a whole bunch more. You get a iPhone app that's got a bunch of cool dashboards in it. And like, I've been playing basketball for a long time, and after an hour playing with this ball, it told me I'm shooting too flat and I need to change the arc of my shot. And I worked on it, and it made a big difference. Amazing. And the point here is, with an instrumented basketball, the role of the coach changes. As a matter of fact, the whole like basketball coaching ecosystem changes, because now the player with the ball can do most of their own work. They can work on their own skills, and the coach can take a much more strategic role. They don't have to teach all the players the same thing at the same time. They can spend their time focusing on individual players' strengths. They can work on drawn up plays and all sorts of things that were really beyond the scope of the normal coach, because the ball is doing a lot of the heavy lifting. And that's what we need to do in security. If a few sensors can change coaching, a few sensors can also change healthcare. Many of you may be wearing an Apple Watch or a phone. I just read that the new Apple Watch is going to measure your blood oxygen level. My daughter has a tachycardia situation, and we need to be able to very quickly monitor her heart. So she wears that, and the doctor doesn't have to be there all the time. In fact, my watch may tell me I'm sick before I know I'm sick, before I would have gone to see a doctor. It can dramatically change the economics of ecosystems that involve experts and players or programmers or patients. And all we had to do was use some instrumentation. So security instrumentation is really powerful. And fortunately, instrumenting software is really easy. It's amazingly powerful. So this is a typical architecture. This is actually a lot like how the Java instrumentation API works. Basically, you write a little instrumentation agent that makes changes to the code as it loads from disk into memory. Okay? You get to register this transformer, and it will actually change the code as it loads at runtime into memory, so that the code you're actually running in memory is a little bit different than the code that's on the disk. We're going to add sensors to this instrumented code so that as the application runs, we can monitor what's going on inside it. That's the essence of security observability. And let's talk about what we can do with that. I want you to think of it like this. Like, imagine, if you're just pen testing an application, this box is a black box. You can't see what's going on inside there. You have to make a lot of informed guesses. And the last talk gave some examples of just how hard it is to detect SSRF inside a running application, because it's not observable. There may be very few signals coming out of that application that will let you know that it actually is vulnerable to SSRF. Some of those blind SSRF examples are incredibly dangerous. If an application has an SSRF that an attacker can use to hit an internal API that's not exposed to the internet, but only for internal use, it could shut down the power system. I've done that attack on, the power controller in a rack, shut down the power. There's a million things that it could do. But if we instrument this application and we've got an agent on the inside, a friend on the inside of the application who can tell us what's going on, we can do much better analysis of security. We can see everything that's going on inside that application. It's white box, but it's white box at runtime. So it's way more informative than what you get from static or from looking at the code. So in this case, really the role of the security specialist can change into sort of defining what the instrumentation should be, where to put the sensors, and what things to gather. The instrumentation does its job quietly in the background, doesn't need any help. And the developer over here just uses the application normally, but they're going to get incredible feedback on what's going on inside the application. So let's take a look at some things we can use this for. This is the entire code. I hate showing code on the screen, but I wanted to just show you, you don't have to really understand all this. I just wanted to show you that it's not complicated to write one of these agents. This is the entire code for an agent that will detect methods that are vulnerable to SQL injection. And in this case, this you can see in here where it says it's searching for classes named, or other that extend Java SQL statement. And it's looking for methods named execute or execute query, because those are the non-parameterized queries. And then whenever we hit one of those, we're going to insert a sensor directly into that method that will just dump out the query and show us the stack trace. So this system out print line here, that's just going to print the query and then print out the stack trace so we can see what's going on. So it's more fun to watch it than to talk about it. So I'm going to use an example here in this ticket book application. It's got a bunch. It's a little bit like WebGoat. It's got a bunch of different lessons here around security. And so to use that agent, all I'm going to do is I'm going to use a very similar agent called Jot, and we'll talk about that in just a second. But I'm going to use this SQL injection rule. It's basically the same as what we just looked at. And then I'm going to run this application normally. Okay, so you can see as this thing starts up, we've instrumented a few methods, and you can see this message that says, hey, Jot is installed and running. And then we'll just use this application normally. So in this case, I'm going to go, click on a few fields here. Let's go to this and let's just type in OWASP. And then you can see that our sensor here, this one does a little bit more than what we were looking at. This actually captures, the information about the method call, the route, and the full query. So here you can see the last query that I gathered was this select star from tickets, where ticket equals OWASP. And there you can see the whole thing. So I didn't have to do any work to get this information. I just had to run this application normally. And because we put a sensor in the right place, now we're going to get alerted every time there's an insecure query. We're going to get a notification of some kind that says, hey, that query should probably have been parameterized. So this is really, it's different than dynamic scanning, because although it's at runtime, it's working from inside the application. And this is different than static analysis, because even though it has insight into the white box, everything that's going on inside this application, it's at runtime. It has much more information than actually just the code. It can look at the data flows, the data values, the backend connections, the libraries and frameworks and how they're used, configuration, anything that you want, you can look at with instrumentation. It's a really powerful way of analyzing an application. Now, look, this was a pretty trivial example. So we're going to do some more exciting examples here in just a second. Oh, one point about this, and all these slides will be available, so you don't have to rush to screenshot anything. You can use instrumentation to fail your test cases. Like, instead of printing that exception, if I'd thrown the exception, then my normal test cases would fail if there's a vulnerability. And that's a really powerful way of communicating with developers, right? Instead of giving them a PDF report, which they're never going to read, what if we give them a failure right in their test suite that they're already using, so that they can, and we can give them all the information they need to fix that problem. That's a really powerful way of communicating and working in a way that's compatible with modern software development. All right, so let's take a look at Jot. So Jot, this is an open source project that I created, and it's a platform for making any Java application observable without writing any code or without even recompiling. It's basically a library that you add to your applications, like jot.jar, and then a set of jots that are basically definitions of sensors that you can use to gather information and then print it out in a really useful format. They're easy to use. I'll show you what jots look like. But the idea here is that you can make pretty much anything in your application observable without a ton of development experience or coding environments and so on. So you can use it to gather information. I'll give you a couple examples here. Like, what if there's a production issue and you don't have enough logs to get the information you need? You don't want to recompile and rewrite and redeploy the application. Instead, you can add Jot and put a sensor exactly where you want in the application to gather just the information that you need and deploy it in minutes. Maybe you want to monitor something that's only accessible deep inside an app. Maybe it's deep in a library and you don't have a way to expose it to your tools. Maybe you don't want to run it in a debugger and try and step through the code to that point. Or maybe you want to prevent abuse of powerful methods by attackers, but they're in libraries somewhere that you don't control. Jot can do that too. So anyway, let's take a look at some of these examples and hopefully inspire you to give Jot a try. So access control is really challenging. Some of you may actually, I see that Garth, can you explain your comment? I see someone says question in the chat. I don't see that chat. Can you ask me the question?
Yeah, so the question in the chat is, if I understand, it's from Carl Hugo Marcotte. If I understand well, it is like aspect-oriented programming focused on the security instrumentation cross-cutting concern. Is it?
That's exactly right. It's using some techniques very similar to aspect-oriented programming, except generally, aspect-oriented programming was a compile time step. So you build the instrumentation in as you were compiling the program, and then it would be there in production. Right. Instrumentation is generally done at runtime. So as the code loads is when you're weaving in those sensors. The result is exactly the same, as you get the sensors in the running application, in the running application, but it's a little bit different procedurally.
Well, while I have you, I'll ask a couple of more.
Yeah,
Martin Kuhn asks, are similar tools available for other programming languages?
Well, sort of. I've tried to make it really easy here for Java. And so, we're going to look at this Jot format over here on the left a little bit. But my idea was to create like that perfect combination of very powerful, but also really easy to use. I think in other environments, that writing custom instrumentation is more difficult. So hopefully we'll have, Jot.net and Jot for Ruby and Jot for Python and Jot for Go and other languages as well.
Hey, Jeff, would this be possible to use with other JVM languages like Scala or Jython or Clojure or things like that?
Yeah, it should work on anything that runs on the JVM. I suppose I could have called it JVM Observability Toolkit, but it's a little kind of a mouthful.
Right, and you, by doing the stack trace, you're able to get you're able to get a location in the code. But can you would it be able to display part of the code snippet that has been misconfigured?
Yeah, I mean, in theory, your instrumentation can grab the code and decompile it and show it to you, but it's probably better to integrate it into an IDE kind of environment and use the line number to just jump to that right line of code.
All right.
Yeah. All right, so let's take a look at this access control thing. So I spent many years testing access control. It was kind of a specialty of mine, and it's really difficult. There's not a good way to know how an application does access control. Almost every application has a custom access control scheme. And it takes a lot of time and effort to log in as say admin and try and find all the URLs, and then log in as user role A, and then try to see if you can access all the admin pages. Then you got to log in as B to see if you can access the admin pages or the A pages, and just really trying all the combinatorics is super difficult. But with instrumentation, you can find out all the access control checks in a much simpler way. So this Jot is designed to identify the routes. So we define 3 sensors and 2 different reports here. The sensors, one is for the routes, one is for the users, and one is for the roles. And then we're going to report a test coverage matrix and an access control matrix. So the routes, we just hook in to the service method, which is every Java HTTP request goes through the service method. And we're going to hook the first parameter and get the URI from it. The first parameter is the HTTP request. So we're going to get the URI from that. This capture is actually a Java expression. Same kind of expression that was used in the Equifax breach, actually, but now we're using it for something good. And it's a super powerful way of sort of navigating around from this method that we injected into. The second thing is we're going to get the users. So the same method, but now we're going to add a sensor that asks for the remote user. And if it's null, we're just going to fill in guest. So this expression now evaluates out how we want. And then the last thing is we're going to find any access control checks. And for that, we're going to look for calls to isUserEnroll, which is a standard Java EE access control check. You can put any method you want here, but we're going to grab the first parameter, which will tell us the role that was trying to be accessed, the access control check for what role. And then we're going to print this out. We're just going to print a test coverage matrix that shows us which users have accessed which routes. And then we're going to print another matrix that shows each route, what access control checks are done on that route. So let me demonstrate that. So I'm going to switch JOTs here. I'm going to switch to my access JOT. And by the way, you can run multiple JOTs at once. You can run a whole directory full of them, or you can just run one at a time. And so here you'll see we're instrumenting, just a few different methods, starting up the application normally. And you should know on performance, like there's a tiny penalty for doing the instrumentation, then a tiny penalty for, running these sensors. But these sensors are so fast, it's almost immeasurable. So I measured, I think it's like, 7 or 8 microseconds that this adds to round trip request. So here you can see I've clicked on just a bunch of links over here, and you can see we're starting to build. We did this automatically, by the way, right? We didn't do anything. We don't have to know anything about security, but we generated a test coverage matrix that says, hey, as guest, I accessed these pages. And here are the access control checks that are done on these pages. So on page A, we check for role A. Page B checks for role B. Page C checks for role C. Hey, wait a minute. Page D, there's no entry here, but look, I hit page D, but there's no access control checks on it. That's a little weird, might be a vulnerability. And then this page, access E here, has 3 different access control checks. And that's a little strange. It's not impossible, but it's a little bit strange. So someone who knows what the access control rules are supposed to be could probably look at this very quickly and say, oh, well, there's a missing check here and there's extra checks here, and we got to go fix that. Getting this data could take days or weeks on a big application, and you can do it almost instantly with instrumentation. I'll switch just to show that I really like having a test matrix, so I'm going to switch users. This is like a little shortcut for logging out and logging back in as a different user. And I'm just going to click on a few of these links just to show you what it's like and how quickly you can get a good measure of what you've actually tested with something like, say, Zap. You could use this, instrument the application in the background, and you could very quickly see like, oh, look, I've tested access A pretty well, but I've got some gaps in access D. I should probably check access D with user D. I should run that test. So this is an important way of understanding how much of the application you've actually tested and what's still out there to be tested. This is just scratching the surface of what you can do with instrumentation to support a pen tester. It's very easy to show exactly where encryption is used. You can look and you could see, so which routes do encryption and what algorithm are they using? You could use instrumentation to show you exactly what parameters are used on each page, regardless of what's in the HTML, but what the application is actually looking for. So if there's a parameter named, super hidden backdoor key, you'll know it, because the instrumentation could just tell you every time the application asks for a parameter, you can record the name of it. Pretty much anything that you're interested in knowing about an application, which routes do forwards to other routes. Just trying to think, which pages do redirects? Where are headers processed? Anything you want to ask, instrumentation can tell you. And a bunch of those JOTs are already created and they're available in the JOT baseline. So you can just look at them and test them out and try them if you want. Okay, any questions on that?
Jeff, we have a question here.
Yep.
I think you mentioned this already, but is the tool able to display part of the code that has been misconfigured?
Yeah, I mean, if you can come up with a sensor for that. So, a good example might be like reading a properties file. You could write instrumentation to read that, to anytime your application gets a property, your code could check it, and it could even have specific rules in it to do some extra validation on that configuration. So, if you wanted to say that you could never turn debug mode off or never turn debug mode on or something, you could make an instrumentation to make sure that debug mode is never enabled. You could check to make sure, say, the application is running using SSL. Pretty much anything you want to come up with, you create a JOT for it pretty easily. And the reason I created this platform is to try to get community involvement to create a huge library of JOTs. Let's make awesome JOTs. If somebody misuses an XML parser, there should be a JOT right there telling them instantly, like, hey, buddy, you should turn off doc type processing so that you don't have an XSE vulnerability. If somebody accesses a back-end connection, like the SSRF talk we were talking about before, actually, just while I was waiting during that talk, I actually started to create an SSRF page in Ticketbook. So you could put in, like, this is a clear SSRF page. Like, I can go to any URL here and access it. And so I was going to create a JOT that showed, exactly where exactly where there's SSRF potential in an application. So you could actually just record, every outbound URL from an application, and then you could very easily check to see if there's, something you can manipulate in that thing.
So Jeff, in those examples, it shows the class, method, and line number where one of the sensors basically went off. Is there a way to actually output the code that was executed there, or is that lost since you're basically at bytecode?
Well, like I said, you could actually dynamically grab the bytecode for that, for the method you're interested in, and you could decompile it and show the decompiled code, which is pretty readable, and show that back to the user. But remember, this is a developer tool, right? So the expectation is that you're trying to create this tight feedback loop to get security feedback back to developers. And so, they have the code right there. If you tell them the line number, they can just, have an IDE plugin or something and just bang right to the code in their IDE.
You mentioned the performance hit. There's a question if performance will be better at compile time, I guess, versus runtime configuration of the sensors.
Not really. The sensors that I'm talking about here are so tiny and so fast. I mean, it's not even a second on startup, and the runtime cost is exactly the same as if you compiled it in. There's just a number of benefits process-wise to using dynamic instrumentation rather than aspect-oriented programming where you'd have to recompile. Like, I can change one of these JOTs And in this, right, currently you have to rerun the application, but we can actually re-instrument the application. I just need to get that working so that you can change the jot on the fly and dynamically create jots to gather the information you want out of the application. So, imagine that you're testing an application and you see, hey, I think there's something squirrely going on when I do this route, and you want to add some instrumentation to it. You don't have to kill the application. You don't even have to kill your session. You could just deploy the jot or change the jot, and instantly you're getting dynamic information out of the application. Any other questions? Okay, because if you like that, I think you're really going to like this. We're going to do an expression language injection example. So some of you may have heard of expression language injection. This is the kind of flaw that took down Equifax. It's riddled throughout struts and Spring and other environments that use expressions. And so this example in Ticketbook has an exploitable expression. Here you can see this is a live expression. If I type in 100, you can see, hey, we evaluated that expression. So this is sort of completing the loop. It's evaluating this expression on the server and then printing the result here. So this can be abused by an attacker. If the attacker enters something like runtime.get runtime.exec open-a calculator, something like that. I always mess this up, but hopefully that's it. I'm going to copy this just in case. You can see that ran and popped up the calculator because that's enough. So in the Equifax example, there was a header that was being sent with an expression kind of like this. And the expression was being evaluated as part of an error path. So you get the application to throw an exception. And as that error page was processed, the user input was processed as an expression and ended up running on the server side. So it's really tricky to find these vulnerabilities, but with instrumentation, we can prevent these vulnerabilities from doing anything dangerous. So let me show you the jot for this. Here we've only got 3 sensors, and only one of them really matters. The first one is the same routes that we used the last time, because we just want to know where these expressions are. The second thing is to detect the use of expressions, and we're going to sandbox them. I'll explain that in a second. And then the last thing is just reporting, and we're just going to report routes and expressions. So we're just going to see where they are. So this one is really the interesting one. And here, what we're going to do is we're going to put our sensor into the process builder method and the socket method. So this will prevent while you're in an expression, and that's what this scope does, is this says while you're inside the evaluation of an expression, you cannot create a socket and you can't create a new process. Those are prohibited. And so we're setting up a sandbox here, and you could expand this set of methods that you don't want to happen. You could add file IO and things like that. But we're going to sandbox these things, and then we're just going to throw an exception. That's what this last line means. We're going to throw an exception with this message. So let's give that a try. We're going to kill this, and we're going to run with our ELI, jot expression language injection jot file. And we're just going to run the application like normal. And you can see we've instrumented a few different methods up here. And now this is interesting. We're going to go back to our page here. And you can see we're still able to evaluate expressions, right? So this is actually really powerful. We're allowing the expression evaluation to happen. But if I enter that same malicious expression, this jot will intervene and prevent that that call from being made. And you can see here, attempt to escape the expression language sandbox was prevented by this jot sensor. And if you scroll down, you can see the exact line of code, and you can see, this page, this el.jsp was running, and it invoked this value expression to invoke the expression. And then a whole bunch of stuff happened. And then deep inside that, the expression caused this runtime.exec to happen, which eventually caused this process builder to run. And that process builder, that's where the JOT sensor is. And that's what ran, and that's what threw this exception. So you can kind of see exactly where the sensor is. And this would be really difficult to try to stop with normal techniques. It'd be very difficult to find and very difficult to stop. So, and then of course, you know, if you just ran this for a while, you wouldn't have to throw the exception. You could just go find all your expressions that are potentially injectable, or you can put this sandbox in place to prevent them from being exploited. Any questions on this one?
I think we're good so far.
Okay. All right, well then a few more thoughts here. So these techniques that I've showed you are essentially IAST and RASP. So IAST just means using instrumentation to detect vulnerabilities. It stands for Interactive Application Security Testing, which is a term made up by Gartner, but it just means using instrumentation to detect vulnerabilities. And it's really powerful. You know, my company, Contrast, was at the forefront of bringing IAST to market. We've been in market for almost 6 years now, and we're used by hundreds, actually we're used on thousands of companies. I think we got, I don't know, so almost 3,000 companies using IAST instead of tools like SAST and DAST to detect vulnerabilities. So I encourage you to, you know, find out about it, take a look and try it. You can write your own with the JOT library. You can create your own simple IAST tools. And it's really powerful. IAST is really powerful at data flow vulnerabilities. I don't know how to do that with JOT yet because it's kind of complicated, but a real IAST can trace running data through the application. So for instance, if you're trying to discover SQL injection, you can actually watch the data as it flows through the app and see it land in a SQL query without being escaped or parameterized or something. So it reports vulnerabilities very accurately. And it's fun to use because you don't have to do any security testing. It's like cheating. And then RASP is simply using instrumentation to detect attacks and prevent exploits. That stands for Runtime Application Self-Protection. And we just did that in the expression language injection example. We just stopped an expression language attack. And again, with real commercial RASP, you can do data flow analysis, and you can, for SQL injection, for instance, you can see, did the user's data change the meaning of the query, and only intervene then. Intervening at the perimeter like a WAF is really kind of primitive. You'll always make mistakes there because you don't have enough information. So that's why IAST and RASP, I think, are really important new AppSec technologies. And ultimately, I think these technologies enable a new way of doing application security. If we can inject the security into the application itself so that it's now kind of self-testing and self-protecting, and then we just run that through the normal dev pipeline. It doesn't slow anything down. It's just there in the background while you're developing, while you're doing your testing, while you're doing your staging and performance testing, whatever. It's just there in the background, finding vulnerabilities and instantly alerting you to them. This runs in real time. So, like for instance, the OWASP benchmark, which if you haven't seen is really cool. It's like 2,700 tests for tools, like AST tools. And, Contrast finishes that in 30 seconds, where other tools would take hours to do the static analysis or the dynamic scan of that baseline. And you get really accurate results. And so, that instant feedback loop is incredibly powerful. And of course, then later in production, you have that same protection and you get that notification of attacks. And so this is why IAST and RASP, I think, are really important and can facilitate a pipeline that doesn't slow down the delivery of value to customers, which is really, the whole point of IT is delivering value to customers. So I do think that this is an important part of the future of application security. And I'll finish with this slide, which I'm super proud of. This shows 3 lines related to the mean time to remediate vulnerabilities. And if you look at organizations that use static analysis, this comes from one of the major static vendors, it takes 30 days to close 29% of the defects and 4 months to close 50% of the defects. And then you get to 71% by the end of the year. That's a really long time and a big window of opportunity for attackers. So using IAST, we've seen much better results. So you can see here, this green line is across thousands of IAST users. And we've seen the median closes in 7 days, 61% in 30 days, and 90% by the end of the year. That's a lot better. But what's really got me excited is this white line, which is for folks using IAST if they have a below average backlog. And what we've seen is as projects use IAST for a little while, they pretty quickly work off their backlog. And then they sort of focus on just the new stuff coming in. And once you've done that, you can get really efficient. This closes 75% in the first 8 days. We have one customer that closes 50% of their vulnerabilities in 1 day and 80% in 5 days. And you can see you get to 95% by the end of the year. So we're really excited about these results because they show, that's over a 40x improvement over static in terms of mean time to remediate. And I think mean time to remediate is really what creates that culture of fixing vulnerabilities right away. I think we all know that's the most cost-effective way to do application security. And so to me, it's like a very different approach to application security than what we've seen in the past. Ultimately, I think that fast feedback can create a platform where development and security can finally work together. So I'm not hopeless about AppSec. I've been doing it 20 years and we're not in a good place, but I do think that there is some hope. I don't think that a technology, by the way, is going to just solve all our security issues. Good security requires that right mix of culture and people and process and technology. But I think IAST and RASP make a nice platform for development security folks to work together as opposed to just banging heads about false positives and busy work all the time. So that's, I think one of the important ingredients of an AppSec program. So I did want to mention, if you're interested in trying security instrumentation on your apps, you can use Jot and write your own Jots. Or if you're interested in commercial IAST and RASP, you could try it for free. Contrast offers a totally free IAST and RASP and SCA product, all in a single platform. You can use it on one application as much as you want forever. It's available for Java and .NET now, and we're going to release Node, Python, and Ruby fairly soon. And if you're a small company and you only have one app, please do this because you can add a ton of security to your application for absolutely free forever. So if any of you try it, please give me a shout. Let me know how it works for you. And with that, I'll stop. And if there's any other questions that folks haven't asked, I'd love to hear them.
I'll kick it off. I have a quick question. I know you had this slide earlier where you had the cool security professional with sunglasses involved in the development of or the building of the rules set. And I'm wondering if you can envision a world where sort of like an extension of test-driven development where the actual developers are building the rules.
Absolutely. So I'd say, some security rules probably need to be built by security specialists. Things like SSRF are kind of complicated and they're not like, custom security. They're just like a weird fluke of the way that people build applications. XXE is the same kind of thing. So a fluke of XML parsing. I don't know why anybody thought that fetching other documents while parsing an XML document was a good idea, but it's in there. So we got to deal with it. So those kind of rules I think are really best for security folks. But if you've got developers that have adopted a policy like, hey, here's how we're going to do access control. every one of our APIs is going to have a call to the is authorized method as one of the first calls. That's great. But now you need something to check that pattern. And JOTs are a really quick way of turning that security into code so that you can add it to a pipeline and deploy it. And if there's ever a violation, you can report it as a bug immediately. Those kinds of rules are best built by developers. Anything where they decide on a security pattern and say, okay, we want to do security logging. Every time there's an access control error, we want to log a message that looks like this. Okay, great. Let's write a JOT that verifies that that actually always happens. So those are really great things for developers to write themselves. But ultimately, I think it's a collaboration between security and development. Work together, build the JOTs, and then after that, security folks can get out of the way and let the big machinery of development do the work. It doesn't scale any other way. You can't scale. If there's experts in the critical path to production, you cannot scale.
I'm 100% with you on that, Joe. Just have you ever thought, like, when I see some of the stuff like injecting in runtimes and stuff, I think New Relic and kind of some of the tools that developers or you might be already used to using and part of your dev chain. Have you ever thought like about, I don't know if this is possible, I never really looked at it from a security lens, but injecting something like this into one of those tools? Have you explored that at all?
We use almost exactly the same techniques that tools like New Relic and AppDynamics use. You're exactly right. It's the same, it's literally the same approach. We just do instrumentation for security. They do instrumentation for performance. And we run side by side. You can run multiple profilers. And so you can run it side by side with New Relic or AppDynamics or any of the other ones.
Okay.
Maybe someday that there's a combined ASM, APM platform, but I'm not sure. It hasn't happened yet. I'm not sure the market's looking for it yet because they're kind of different budgets and different buyers. But
I agree. I think it would be interesting though, kind of your point, like people are already used to using like those tools and there's budget for them for other reasons like performance and making sure the app's running correctly, monitoring it. So it might be an easier integration. I just don't know like if there's integration points and whatnot, but it's interesting.
You know what? It's actually like we get almost no pushback from development teams and operations teams on this. Sometimes they ask a question like, does it create a security risk? This adding an instrumentation module to it, does it create its own security risk? And, once they think it through, they realize, it really doesn't. It's the exact same risk of using any open source library. Because there's really no attack surface, right? There's nothing exposed externally. So it's just like, in fact, in a lot of ways, it's less risk than an open source library. So we haven't had that problem. Really, the cultural adjustment from security folks is really the biggest challenge. Many security folks, they just think about scanning. They don't have access to a running application. They don't even know how to do that. Like, could they go install an agent on a running bot? Not a chance. They can get to the source code repo, maybe, or they can pen test with something like that. But that's the cultural change, is that security needs to walk over to the development team and say, hey, can we try working on this together?
Yeah, I agree, Hunter. I used to run a security organization. Now I run a development organization, so I can see the both sides of it.
Yeah.
I definitely agree with your comments there. I think, and have you had New Relic? Just one question: have you had New Relic profiling and this profiling at the same time? Any performance issues with running two profiles at once, or not?
No, the cost of running a profiler is really just based on how expensive the sensors are. You can write a sensor, like the sensors I showed you today are trivial. They're almost immeasurably fast. But if you're doing full data flow analysis, those sensors are doing some significant work. And so there can be performance hits. Just like, like when you run a New Relic or an AppDynamics, you're probably going to notice the performance hit. Same thing with security instrumentation. We generally, contrast maybe adds 5 milliseconds to a round trip request. So you wouldn't want to put it in production in assess mode, because that's sort of the more expensive thing. In production, you use RASP, which is sort of highly tuned for being really fast. There, it's more like 50 microseconds on a round trip request. So just to give you a ballpark, like if you're a developer using these instrumentation, you'll never know it's there.
Okay, thanks.
Well, if there's no more questions, I hope you give it a try. I think it's, and you'll definitely learn something about security from trying this approach. And please don't hesitate to reach out. My handle's Planet Level on Twitter. Reach out on LinkedIn anytime, and happy to talk about this stuff.
I'll ask one quick question while I'm not on mute. Question from the chat, and I think I know the answer to this, but I'll ask it just in case, because it is open source. Can you customize the output?
Yeah, so with Jot, you can customize the output in a bunch of different ways. There's a bunch of different reports that you can make, whether it's a list or a table or a log file or whatever. With contrast, you can get the output a bunch of different ways. All the data in contrast, imagine you've got all your applications instrumented and they're all continuously monitoring. They're all reporting vulnerabilities to a central dashboard that's always up to date. And then that data is available there in the dashboard, but really where you want it is in the tools that developers are using, and in your Jira and in your Eclipse and in your Slack and in your Jenkins. And so we've got integrations to all those things so that you can get the data in the tools that you're already using. It's everything in contrast is accessible via a REST API. So you can also, pull it down that way and make your own reports. But it's important. I think I want to just try to make everybody get behind the death to PDF movement.
Yes.
Because it just doesn't work. It's like a bad code smell for a security process. It just doesn't work.
That's the PDF and shit to the left. That's the two things
Yeah,
I took away from this talk.
Don't shit left. Don't use PDF.
I think developers would want to use Jot because, the best way to secure code is with more code, obviously.
I hope so. We'll see what people build with it. That's one of the coolest things I've launched, because I really don't know how people are going to use it. The security uses are actually just scratching the tip of the iceberg. There's a ton of uses of Jot that it could just be for just debugging purposes and just, understanding what's going on. A lot of times you get that situation where, I don't know, there's something going wrong inside this scope and I can't figure it out. Maybe it's swallowing an exception and nothing's getting logged or whatever. Jot can let you, I really think of it like if you had a machine and you were like running electrical probes into it, and sticking it like right on a resistor or something just to measure the current. Like it's a lot like that. You just put the sensors where you want, gather the data, and look at the oscilloscope.
All right. Any final questions? I think this was an interesting talk.
I only see death to PDF being repeated.
Is there a .NET version of your tool, your Jot tool? I don't think so, right?
Well, here's what you do. If you're in OWASP and anyone ever asks you for an enhancement, you ask them to do it. Okay, so look, I'm looking for volunteers to help me with Jot. Projects at OWASP that are one-man bands don't survive.
Yeah.
And I've seen it over, like WebScarab used to be the greatest tool in the world. And, it was just a one-man shop. Rogan Dawes, I worked with him for a long time. But when he stopped doing it, the project died. And that's how Zap came to be. And a few projects at OWASP have reached escape velocity. I'm proud to have written WebGoat, which people are still using for some reason. But it wouldn't have survived if it was me, because I quit 10 years ago or whatever. So it's because of Bruce Mayhew that project has stayed alive and gotten a bunch of contributors. The testing guide, bunch of contributors. OWASP Top 10, bunch of contributors. But projects that are just one-man bands just tend to die on the vine. So I'm absolutely looking for contributors. It's a super fun, I think Jot will be a super fun adventure as we grow it and build out a bunch of Jots and build out other languages. The .NET Profiler API is pretty similar to the Java instrumentation API. So I feel like it should be relatively straightforward to go build that.
Another question, is that 225 in the back I see there? Bench press?
Oh, I wish.
It's a background.
I'm working on pull-ups though. Pull-ups is the way to go.
Awesome. All right, just kind of seeing if the chat calms down. I think it has. A lot going, gone. Last chance, everyone.
Waiting for the delay.
Yeah, looks like we're good. Thanks so much, Jeff. Thanks so much, Garth. It was I think a really good OWASP session. So I really appreciate everybody coming out for the COVID edition of OWASP. Hopefully we'll do another one of these soon.
Thanks a lot, Michael.
All right, thanks
See you guys.
everyone.
Bye.
Take care. Bye.